Okay, yesterday you watched two videos. The first video was dealing with molar volume. The second one was dealing with density. So, we have now completed our flux capacitor. So, this part of the flux capacitor that we learned yesterday, the bottom left part, the one dealing with here, the mole going to the volume, so the mole down here to the volume, is what we dealt with. Now, when we talked about the molar volume, we needed to have a certain amount of a couple conditions that were met in order to be able to do this. What were they? What were the conditions necessary?
The pressure has to be at 1 atmosphere.
We need to have 1 atmosphere of pressure, and we needed to have 0 degrees Celsius. So we needed 1 atmosphere of pressure, 0 degrees Celsius. That is what we call standard temperature and pressure. We abbreviate that STP. So if something is at STP, it's at standard temperature standard temperature 0 degrees Celsius. It's at STP, it's at standard pressure 1 atmosphere of pressure. So if we have those conditions, if we have STP, any gas will have a volume of what? 1 mole of any gas will have the volume of what, Sarah? 22.4 liters. Any gas, 22.4 liters. So, if I have STP, what's the volume of 1 mole of oxygen? 22.4 liters. If I have STP, what's the volume of 1 mole of nitrogen? 22.4 liters. Okay? Let's deal with a compound. Okay? Let's deal with the compound. Let's talk about some molecules. What if I have STP? How much is 1 mole of methane gas? CH4. 1 mole of that would be 22.4 liters. What would 1 mole of carbon dioxide be at STP? 22.4 liters. So does it matter what the gas is? Does the gas matter? No. Okay? The conditions matter if we have standard temperature and pressure. Now, do we talk about the molar volume of a liquid or a solid? This is only volume of a gas. So that's important. The volume of a gas. Now, we've completed the bottom end of our flux capacitor here. So if I'm following mole, this little green arrow down here, I set up my conversion box here on my green arrow. And if I'm going from moles to volume of the gas, I want the 1 mole on the bottom. I want the 22.4 liters on the top. Now, my conversion box, if I'm going from volume of a gas up to mole, I'm going to have the volume on the gas on the bottom, and I'm going to have the 1 mole on the top. So this will complete my flux capacitor. So let's go through and let's look at some of these problems. So the very first one here, go ahead and copy this down into your notes and then we will work it. The question states how many moles are there in 238 liters of carbon dioxide at STP? Well, we have STP. So at STP, we know a molar volume. So I'm going to start out with 238 liters. Now, when I do my conversion to moles, I put together my conversion box. What do I want to cancel on the bottom? What label? Liters, right? So on my factor label method, I know that I need 22.4 liters of carbon dioxide on the bottom. That equivalent is 1 mole of carbon dioxide. So if I look at my labels that cancel, my liters both cancel, my final answer is going to be mole of carbon dioxide. So what I need to do is I need to take the 238 and I need to divide that by 22.4. And when I do so, I get a value with 3 significant figures of 10.6 moles of carbon dioxide. Now, as you see, folks, as you're going to see here, I'm going to just throw step by step some new things at you here. So, this is the easiest one of the bunch. Now, I think this one's pretty easy because it's a lot like Avogadro's number. You have a set value. Your molar volume is set. Unlike the molar mass. The molar mass is going to change with every atom, with every molecule, with every formula unit in it, okay? Because those values are obviously different. Now, this second one, here, go ahead and copy it and see if you can see if you can identify what I've thrown at you that's different. Now, the new thing that I threw at you here is milliliters. Okay? We've been talking about liters, haven't we? We haven't been talking about milliliters. You could do this a couple of different ways. What I do, folks, is I know that 22.4 liters is equal to how many milliliters would that be? How many milliliters would 22.4 liters be? Anyone? Anyone good at metric conversions? 22,400. So 22.4 liters is 22,400 milliliters. So if I'm doing my conversion, I have 8.66 mole of oxygen. I set up my conversion box. I want my moles to cancel, so I'm going to put 1 mole on the bottom. 1 mole of oxygen is equal to 22.4 liters, but I don't want it in liters. I want it in milliliters. So I'm going to put the 22,400 milliliters. Is that still an equality, folks? Is this right here still an equality? Is 1 mole equal to 22,400 milliliters? Yeah, that's still an equality, okay? So I still get my cancellation of my moles, so I know that my label's going to be milliliters of oxygen. When I do my math, I just take the 8.66 and I multiply that by 22,400, 22,400, and I get a value of, with 3 sig figs, 1.94 times 10 to the 5th. That is my value in scientific notation. Now, somebody asked me in my other class, Mr. Braun, what if I would have put that? What if I would have put that? 194,000 milliliters. Yeah, it's the same thing, only it's not in scientific notation. Okay? 6 to 1, half dozen the other. Okay? Just means it doesn't matter. It's the same. Okay? If I see this value, I see this value, whichever one you write. Okay? So it could be either or. Next example problem. Okay? Next example problem gives us a little more. We're building a little bit greater. How many liters are there in 6.18 grams of sulfur trioxide at STP? So what's the new portion here? What am I throwing at you different now? I'll give you a second to copy it. So what am I throwing at you different now? What's different with this problem than any of the others that we've done yet today? Okay, I have grams now, right? Is there any way that I can go from grams to liters? Okay. Can I go from grams to liters? Not directly. I need to go through moles. Okay. So, as I do this part, I take the 6.18 grams of SO3, and I need to convert that to moles. Well, in order to do so, I'm going to need to know the molar mass. Well, I already know the molar mass because I've already calculated it. It's 80.0632 grams of SO3 is 1 mole of SO3. Now, when I have done so, do I get my labels to cancel? I've got grams SO3, I've got grams of SO3, so I have now converted this into moles. Is that what I want to do? No, I need to go one more step. I need to go to volume. So I know that 1 mole of SO3, I want that on the bottom so it'll cancel, is equal to 22.4 liters of SO3 because I know that I am at standard temperature and pressure. My moles of SO3 cancel. My final label is going to be liters of SO3. Now I need to do my math. I multiply by things on the top. I divide by things on the bottom. So I take 6.18. I divide it by 80.0632. And then I multiply that value by 22.4. And I get a value with 3 significant digits of 1.73 liters of SO3. Now that's a 2-step problem, folks. Can we give me a thumbs up on the 2-step? Okay, get them nice and high so I can see them. Making sure on my check that everybody's got that. It's a two-stepper. We're good with it. Good. Good. Well, now that we're good with those two steps, let's get this guy down and work a little bit of density. What is the density of phosphorus trifluoride gas at STP? I know density is mass over volume, correct? So, if I were to tell you the molar density would be equal to what? What would the molar density be equal to? The molar mass over the molar volume. Wow! Can I get the molar mass of phosphorus trifluoride? Absolutely. I just add them up. So when I did so on the periodic table, I saw that my phosphorus trifluoride had a molar mass of 87.969 grams. What is my molar volume? At STP, my molar volume of a gas is going to be 22.4 liters. So, what is my label for this going to be? Grams over liters. Grams per liter. And I do my math. I take the 87.969 and divide it by 22.4, and I get a value of 3.93 grams per liter. Now, my final example is right here. What is the molar mass of the unknown gas that has a density of 0.7910 grams per liter at STP? Oh my gosh, Becky, we have an unknown gas. Does that matter? Does it matter that we don't know what gas it is? No. What matters is, A, we're at STP, are we? Yes. B, at STP and the gas, we know the volume, don't we? Okay? So, as I'm looking at this, I say, well, density equals mass over volume. Well, that means that mass is equal to density times volume because I can manipulate my equation. Once I've manipulated my equation, I say, all right, I have a density of 0.7910 grams per liter. I have a volume because we are at STP, and I have a gas, 22.4 liters. My liters cancel out, leaving me with a label of grams. Is that a good label for a gas? Excuse me, check. Is that a good label for a mass? Yes, it is. So I need to take the 0.7910, multiply that by 22.4, and I get a value with four sig figs, 17.72 grams. And I don't know what gas it is, but I know that the molar mass is 17.72 grams. What do you think? Thumbs up? We okay? All right.